So to define a destructor is like, it's very simple. Just declare it and then create its definition, right? If you don't need to do something like this, if you don't bother, using dynamic memory like we do here, you don't need it. It's, I mean, you can still do this, right? Just define an empty function, but it's probably not recommended doing it just for the purpose of, I don't know, just to show that you know that destructors exist. In this case, you don't need it. But in our case, it's very important, very, very important to have it, because it's just, you never know how your objects are going to be used. So therefore, returning memory when appropriate is a great idea. All right. So destructors. As we have a chain of constructors, remember, we discussed that the execution of constructors is very predictable. Likewise, the chain of destructors is also incredibly predictable. And that's sort of like a symmetrical mirror image of constructors. If we had this code, Honda, and it for the moped user defined class, and it had a number of things, engine, which had cylinders, which also then had transmission and things like that. The execution of destructors is exactly the opposite. So if we had two wheels declared someplace at the end of the class name moped, their destructors are called first, then the transmission, then the destruction of the engine, destructor of the engine, and then it would also call the destructors of the cylinder. Exact opposite, right? Exact opposite, symmetrical approach to that. So very predictable. So not only that you can rely in the design of your program on the chain of constructors, you can also rely on the chain of destructors as well. And then when I gave you this little example with me, and I'm not sure how clear this was, but again, if I wanted to say, let me actually try to clear it off a little bit and say, all right, I have this program, right? And it's just a series of functions, right? Series of functions. So this is my source code or multiple source code. And so these are my all kind of functions that I create. And of course, these functions at runtime begin to call one another. So let's say this one is main right here. So main calls this one. This one calls this one. This one calls another one. This one could potentially also call this one somehow and then return, right? And then this one returns, right? And then this one returns, and I'm back in main. Then main could call this function, and so forth and so forth. So looking at the source code and finding out what is the true picture that happens at runtime is not exactly the same. It's not exactly obvious. I can challenge you right here, like, look at this code, it has grown to some level, and here as well. Can you tell me, like, really quick exactly what is happening at runtime? No way. It's way too much to take on. You really have to maybe like set a breakpoint somewhere here, and then try to execute it step by step, and then maybe say, oh, now I kind of know what's going on. So in the form of proactive debugging, you could do this. Your life can be simplified greatly by saying, how about this? In each single one of these functions, I create a little object. As soon as the function is called, create an object, right? And so the object will be sitting there as long as this function is still doing something. When the function returns, we know that the destructor with the tilde in front of it is going to be invoked. So first the constructor is invoked, and then the destructor is invoked. So therefore, if I watch if every single function, for the purpose of tracing and understanding how this program works, if I created those little objects and somehow their constructor like took the name of the function, simply by executing this program, I can produce very reliable trace of everything that is taking place inside this program. In fact, I do this a lot. I do this quite a bit, and I think I can give you an example, by the way, right away. Hopefully, if I still have it here, say diagrams, and if I, for example, when you log in into your quiz, application, this is what happens. So here's the trace of functions. This is what happens, and that was produced exactly by this thing, right? So then when you say I want to take a quiz, where was it? When you say I want to take a quiz, this is, for example, a practice run right here. This is what's happening in there, and this is a, these are the objects and functions that are involved, and this is the timeline. And so when the next time I have to change something in this code, I actually go here first, because I want to know what the big picture is, right? So those graphics were produced by this approach, having little trace objects which tell something as soon as we enter a function and as soon as we exit from it. And this is actually the result of doing exactly that. So we may come back to this in the future. This is, by the way, called a sequence diagram. Right, it's way over time for me.